Hi everyone, this is our first lecture for Unit 5. We're starting Unit 5, it's a long unit. It has a lot of different topics, so please pay attention over the course of this unit and take good notes. Well, the topic for this video is molarity. We'll talk about molarity and dilution by molarity. Molarity means concentration. Okay, for example, you want to prepare a solution of salt and water. So you take a glass of water, okay, and you put some salt in this. For example, you put 3 spoons of salt in this. Okay, then you take another glass of water, same amount of water, okay, and you put 12 spoons of salt in this. So of course, this one is going to be much more salty than this, because here you have 3 spoons of salt, here you have 12 spoons of salt. Okay, so because the concentration of salt is much more in glass B compared to the concentration of salt in glass A. Okay, so that concentration is known as molarity. So molarity means concentration, how much of a solute is in the solvent. For example, in this example, we have much more solute, 12 spoons of salt, which is a solute, versus 3 spoons of salt. So to calculate the molarity, to calculate that concentration, we will take moles over liters. We don't take spoons. We do not use grams. Even if you are given grams, you have to divide it by the molar mass, okay, to convert it into moles before you plug it in. So you cannot plug in grams right here. You have to cancel the grams, convert it into moles. If you are given milliliters, you have to convert it into liters before you plug it in. 1 liter is equal to 1000 milliliters. Write this down in your notes. We will be using it in class. So 1 liter equals to 1000 milliliters. So in the questions, the question will be asking you calculate the concentration. Not necessarily question will say calculate molarity, because after you learn this, we assume that once we say concentration, you automatically know it is molarity. So molarity is the concentration, capital M. Don't say small m, because it's molality. It's a whole different term. So capital M equals moles over liters. You have to memorize the formula. So you can also do this. Okay, let me do the triangle on a different page. There are two ways to do this, like molarity equals moles over liters. So to calculate the molarity, you will take moles divided by liters. To calculate the volume, you will take moles divided by the molarity. Okay, you are dividing it this way. And to calculate the moles, you will multiply molarity and liters. Or you will know molarity equals moles over liters. So if you have to calculate the molarity, you of course take the moles divided by liters. If you have to calculate any of the other, like moles or liters, you can cross multiply it. So there are different ways to calculate moles and liters out of the same formula, but you need to understand what the formula is and how it works. Let's do some examples. So higher the molarity is, higher the concentration is. That means you have much more solute in the solvent. Let's do this example. Determine the molarity. So you need to calculate the M. You have the volume, which is the liters, and you have moles. So to calculate the molarity, it is moles divided by liters. Your moles are 4.5 moles divided by 1.75 liters. So the answer is going to be two significant digits, because you have two sig figs here and 3 here. So the answer is going to be two significant digits. Let's go ahead and do it in the calculator. So give me a second. I'm going to take 4.5 divided by 1.75. My calculator is telling me it is 2.57. As I said, I'm going to take only two significant digits, which is right here. So my answer is going to be 2.6 molar. This is the unit. Capital M is the unit of molarity. So let's do the other example. Determine the moles of sodium chloride. So I have molarity equals moles over liters. This M is telling me I have molarity. So this is 3.00, this capital M. Okay, 3.00. I don't have the moles, and the volume is 2.75 liters. So as I said, to calculate the moles, I will cross multiply it. So moles equals 3.00 multiplied by 2.75. So let's plug it into the calculator. The calculator is giving me 8.25 moles. I need three significant digits because I have three significant digits here and three significant digits here. Let's do the other question. Determine the volume. Okay, you're calculating the volume. This capital M tells you you have the molarity. Okay, and here are the moles. So molarity equals moles over liters. Okay, you have by this time you would have memorized the formula of molarity, moles over liters. So I have molarity 2.50. I have 7.5 moles. I don't have the liters, so I cross multiply it. So 7.5 times 1 equals 2.50 times liters. So to calculate the liters, I divide both sides by 2.50. So 7.5 divided by 2.50 gives me 3. Okay, but I need to have at least two significant digits in the answer. I have 2 here and 3 here, so I will say 3.0. So 3.0 liters is your answer. So go ahead and do these questions. You must understand that 1 liter equals to 1000 milliliters. Okay, this is a relationship you need to understand. 1 liter equals to 1000 milliliters. This question number 4, what is the molarity? Okay, molarity is moles over liters. Now what do I have here? I have 125 grams of NaCl. I told you we cannot use grams in the formula. We have to convert it into moles. So I'm going to first of all take 125 grams divided by the molar mass of NaCl, which is 58.05 grams, equals to 1 mole. Okay, this information is coming from the periodic table. I'm adding the mass of sodium and chlorine. Once I calculate the moles, I plug it in here and I divide by the liters. What is the molarity? Again, I have moles over liters. Okay, to calculate the milliliters into liters, I will do 400 divide milliliters. So 1000 milliliters is 1 liter. Okay, 1000 means my decimal point goes here. So molarity equals 30. You know, this decimal point means you have two significant digits here. Divide by 0.4. Okay, I have three significant digits here. So 0.400. And this is how you calculate, because you need to convert it into liters. So 0.400 liters is your answer right here that you plug it in, moles over liters. So this is how you calculate the molarity. You have to divide it, and that will give you the molarity. So this is how you calculate concentration of a solute into the solvent. For example, you have let's also get the concept here. When we prepare a molar solution, we take a flask. Okay, this flask has 1 liter on it, and okay, it has 1 liter on it. So what I do is, if I'm preparing sodium chloride solution, which is a 58 grams, you know, 1 mole of NaCl, 1 mole of NaCl is 58.05 grams. So if I take 58.05 grams and I take some water, dissolve it, and then fill it up to 1 liter, okay, this is 1 molar solution. If I want to prepare 3 molar solution, of course I will take 58.05 multiplied by 3. Okay, so let's do that. 58.05 times 3 gives me 174.15 grams of NaCl. okay, to prepare 3 molar solution. So you understand that how much more solute I have in the same volume, 1 liter, versus this. So this is a concentrated solution, okay, it has more solute in it. This is a dilute solution. For example, if I want to dilute in any more, let's say I want to prepare zero point 0.1 molar solution. So if I want to prepare zero point 0.1 molar solution, how much salt would I take? 0.1 molar means I'll take 5.805 grams and dissolve it in the 1 liter. This is 0.1 molar solution. So this is even dilute solution. You know, this is very dilute solution because it has only 5.8 grams of sodium chloride versus this one 1 molar 58.05 grams versus 3 molar. So this number itself tells you how concentrated the solution is. I don't really need to know any more information. It tells me right here this is the most concentrated solution, and I have to deal with care when it comes to this. So that's all about molarity. In the next video we will learn about molarity by dilution.